Hello and welcome to the Sleepy Physicist. I'm so glad you're here. Whether you're settling into bed, curling up on the couch, or just trying to wind down after a long day of pondering the mysteries of existence, you've come to the right place. This is a quiet corner of the internet where quantum mechanics gets soft-spoken and consciousness puts on pajamas. Tonight, we're diving into one of the most extraordinary frontiers in science, the idea that your brain might be connected to the very fabric of the universe through quantum mechanics. Imagine for a moment that right now, as you listen to these words, tiny structures inside your neurons are performing quantum computations that classical physics says should be impossible at body temperature. Yet recent experiments suggest they're happening anyway. And if this is true, it could mean your consciousness isn't just trapped inside your skull, but potentially entangled with the quantum field that underlies all of reality. It's a journey that takes us from the deepest mysteries of the mind to the strangest corners of physics, and a few surprises that might just change how you think about what it means to be you. Now, I do hope this video isn't so fascinating that it keeps you awake. But hey, if it does, at least you'll be contemplating the nature of consciousness itself a fair trade, I'd say, before we begin. If you enjoy these gentle explorations into the deepest questions of science and existence, I'd be ever so grateful if you tapped the like button, subscribed, or even just left a comment telling me where in the world you're watching from and what time it is in your corner of the universe. Alright, take a deep breath, settle in, and let's begin our quiet voyage into the quantum nature of mind. What if I told you that the answer to consciousness, the hardest problem in science, might be hiding in the smallest possible spaces inside your brain right now? As you process these words, tiny hollow tubes called microtubules are vibrating at frequencies that classical physics says should collapse instantly in the warm, wet environment of your neurons. Yet somehow they persist, and according to a growing body of research, they might be the key to understanding not just consciousness, but how your mind connects to the quantum fabric of reality itself. This isn't science fiction, it's the quantum consciousness revolution, and it's happening in laboratories around the world, from Wellesley College, where researchers have discovered that anesthesia works by disrupting quantum processes in microtubules, to Trinity College Dublin, where scientists may have detected quantum entanglement in living human brains. The evidence is mounting that consciousness operates on principles far stranger than we ever imagined. Let's start our journey where it all began with a simple yet profound question that has puzzled philosophers and scientists for centuries. How does the 3-pound lump of tissue in your skull generate the rich inner world of your conscious experience? When you see the colour red, feel the warmth of sunlight on your skin, or experience the bittersweet pang of nostalgia, what exactly is happening that creates these subjective experiences, and why do you have them at all? This is what philosopher David Chalmers famously called the hard problem of consciousness. It's not just about how the brain processes information, that's the easy problem. Relatively speaking, the hard problem is explaining why there's something it's like to be you, why you have an inner life at all rather than being a sophisticated biological robot processing inputs and generating outputs with nobody home upstairs. For decades, neuroscientists have assumed that consciousness emerges from classical computational processes in the brain. Billions of neurons firing in complex patterns, creating networks of activity that somehow give rise to subjective experience. But there's a problem with this view. It doesn't actually explain why these processes should feel like anything from the inside. You could theoretically have all the same neural activity, all the same behavioral outputs, without any conscious experience whatsoever. This explanatory gap between brain activity and subjective experience has led some researchers to look beyond classical physics for answers, and what they found in the quantum realm is both strange and beautiful quantum mechanics. The theory that describes the behavior of matter and energy at the smallest scales operates on principles that seem to defy common sense. Particles can exist in multiple states simultaneously, a phenomenon called superposition. They can be instantly connected across vast distances through entanglement, and they can tunnel through barriers that should be impenetrable. For most of the 20th century, scientists assumed that these quantum effects were too delicate to survive in biological systems. The brain is warm, wet, and noisy, the antithesis of the carefully controlled conditions needed for quantum phenomena. Or so we thought, but nature, it turns out, is far more clever than we gave it credit for. The story of quantum consciousness begins with an unlikely partnership between Sir Roger Penrose, a mathematical physicist and Nobel laureate, and Stuart Hameroff, an anesthesiologist. Their backgrounds couldn't have been more different, yet they shared a conviction that classical physics alone couldn't explain consciousness. In the 1990s, they proposed a radical theory called orchestrated objective reduction, or Orch-OR for short. According to their theory, consciousness doesn't emerge from the classical firing of neurons, but from quantum computations happening inside structures called microtubules. These are tiny hollow tubes that form the cytoskeleton of neurons, giving them their shape and helping transport materials throughout the cell. But Penrose and Hameroff suggested they serve another, more exotic function as quantum computers. The idea was initially met with skepticism, and for good reason. Quantum effects typically require temperatures near absolute zero to prevent decoherence. The process by which quantum superpositions collapse into classical states, the brain operates at a balmy 37 degrees Celsius, hardly the kind of environment where delicate quantum states should survive. Critics argued that the brain was simply too warm, wet, and noisy for quantum consciousness to be possible. But then something interesting happened. As researchers began studying quantum effects in biological systems, they discovered that nature had found ways to protect and even exploit quantum coherence at room temperature photosynthesis. The process by which plants convert sunlight into energy was found to use quantum superposition to explore all possible energy transfer paths, simultaneously achieving near-perfect efficiency. Bird navigation systems appear to rely on quantum entanglement in certain proteins to sense magnetic fields. Even our sense of smell might involve quantum tunneling effects. Suddenly, the idea that the brain might harbour quantum processes didn't seem quite so far-fetched. And then came the experimental evidence that would change everything. In recent years, multiple studies have provided support for quantum effects in microtubules. Researchers at the University of Alberta shined light into microtubules and observed quantum coherence lasting far longer than classical physics would predict, up to nanoseconds in some cases, which is an eternity in quantum terms. Another study at the University of Central Florida found that microtubules could maintain quantum states for up to a second, providing ample time for quantum computations to influence neural activity. These findings suggested that microtubules weren't just passive structural elements, but active quantum processes capable of the kind of coherent quantum activity that Penrose and Hameroff had proposed. But perhaps the most compelling evidence came from an unexpected source: anesthesia research at Wellesley College. In 2024, researchers made a startling discovery. They found that anesthetic drugs, which reliably induce unconsciousness, don't just affect neural firing patterns, they specifically bind to microtubules and disrupt their quantum activity. When they gave rats drugs that stabilize microtubules, the animals took significantly longer to lose consciousness under anesthesia, suggesting that disrupting quantum processes in microtubules is what actually causes the loss of consciousness. This finding was revolutionary because it provided a direct link between quantum processes and conscious experience. If consciousness were purely classical, disrupting microtubules shouldn't affect it, but the fact that stabilizing these structures delays unconsciousness suggests that quantum activity in microtubules is indeed necessary for conscious awareness. The implications are staggering. If consciousness really does operate through quantum processes, it could explain some of the most puzzling aspects of the mind, why consciousness seems unified despite being generated by billions of separate neurons, why we can process information in ways that surpass even the most sophisticated computers, and perhaps most intriguingly, why consciousness might not be confined to individual brains at all. Quantum entanglement. The phenomenon Einstein called spooky action, at a distance allows particles to remain connected regardless of the distance between them. When two particles are entangled, measuring one instantly affects the state of the other. No matter how far apart they are, this connection transcends space and time, operating outside the normal constraints of relativity. If consciousness really does involve quantum processes, then it's possible that individual minds could be entangled with each other and with the quantum field that underlies all of reality. Recent experiments at Trinity College Dublin have provided tantalizing hints that such entanglement might actually exist in living brains. Using sophisticated MRI techniques, researchers detected signatures that could indicate quantum entanglement between different brain regions. While the interpretation of these results is still debated, they represent the first potential evidence of quantum entanglement in living biological systems. If these findings hold up, they could revolutionize our understanding of consciousness and our place in the universe. Consciousness wouldn't be a private, isolated phenomenon trapped inside individual skulls, but part of a vast, interconnected web of quantum information that spans the cosmos. Your thoughts, feelings, and experiences might be entangled with the quantum structure of reality itself, connecting you to the universe in ways we're only beginning to understand. But let's not get ahead of ourselves. The quantum consciousness theory, while supported by growing evidence, still faces significant challenges and criticisms. Many neuroscientists remain skeptical, arguing that classical neural networks can explain most aspects of consciousness without invoking quantum mechanics. The success of artificial intelligence systems like ChatGPT in mimicking human cognition suggests that classical computation might be sufficient to generate intelligent behavior. Moreover, the quantum effects that have been observed in biological systems, while impressive, are still far from proving that they're responsible for consciousness. It's one thing to show that microtubules can maintain quantum coherence. It's another to demonstrate that this coherence is necessary and sufficient for conscious experience. The gap between quantum processes and subjective experience remains as mysterious as ever. There's also the question of what exactly quantum consciousness would mean for our understanding of free will identity and the nature of reality. If our minds are quantum systems operating according to the probabilistic laws of quantum mechanics, are our choices truly free, or are they simply the result of quantum randomness? If consciousness can be entangled across space and time, what does that mean for individual identity and personal responsibility? These are not just academic questions. They touch on the deepest aspects of human existence and meaning. As we continue to probe the quantum foundations of consciousness, we may find ourselves confronting profound philosophical implications that challenge our most basic assumptions about reality. Yet there's something deeply beautiful about the possibility that consciousness might be woven into the very fabric of the universe, that the subjective experience of being you isn't an accident of neural computation, but a fundamental feature of reality itself. It suggests that mind and matter aren't separate domains, but different aspects of a deeper underlying unity, a quantum field of pure information and possibility from which both physical reality and conscious experience emerge. This idea isn't entirely new. It echoes ancient philosophical traditions that have long suggested the interconnectedness of all things. But now we have the tools of modern science to explore these possibilities with unprecedented precision. Quantum field theory, information theory, and neuroscience are converging to paint a picture of reality that is far stranger and more wonderful than our everyday experience suggests. As we continue this exploration, we'll delve deeper into the experimental evidence for quantum consciousness, examine the mechanisms by which quantum processes might give rise to subjective experience, and consider what it would mean for humanity if consciousness really is a quantum phenomenon that connects us to the cosmos itself. we'll explore how quantum biology is revealing the universe's hidden quantum nature, from the quantum compass in migrating birds to the quantum efficiency of photosynthesis. We'll investigate the latest experiments that are probing quantum effects in living brains, and we'll grapple with the profound implications of a quantum theory of consciousness for our understanding of reality itself. But that's a journey for the next part of our exploration. For now, let yourself rest in the wonder of these possibilities that your consciousness, this most intimate aspect of your being, might be part of something far grander than you ever imagined, a quantum symphony playing out across the cosmos, with your mind as both instrument and musician. Sleep tight knowing that the universe might be dreaming through you. And in the next part of our journey, we'll explore exactly how that cosmic dream unfolds through the quantum mechanics of your brain. But there's one more mystery we need to unravel first. How does your brain create the rich, detailed reality you experience every moment when that reality might not be what it seems at all? Stay tuned for how your brain creates a reality that isn't there, where we'll discover how your quantum consciousness constructs the world you think you know. The quantum revolution in consciousness research isn't just happening in theory, it's unfolding in real time in laboratories around the world, and what scientists are discovering is challenging everything we thought we knew about the relationship between mind and matter. At the University of California, researchers have been mapping the quantum signatures of anesthetic effects on consciousness, finding that as patients slip from awareness to unconsciousness, there's a measurable collapse of quantum coherence in their brain tissue. It's as if consciousness itself has a quantum fingerprint that vanishes when we lose awareness and returns when we wake. This discovery has profound implications because it suggests that consciousness isn't just correlated with quantum processes, it may actually be identical to them. When you experience the red of a sunset or the melancholy of a rainy afternoon, you might not just be having classical neural activity that corresponds to these experiences, you might be directly participating in quantum computations that exist in a superposition of possibilities until the moment of conscious observation collapses them into definite experiences. But here's where things get really interesting. Quantum mechanics tells us that observation plays a fundamental role in determining reality. The famous double-slit experiment shows that particles behave differently when they're being observed, suggesting that consciousness and physical reality are intimately connected in ways we're only beginning to understand. If consciousness really is a quantum phenomenon, then every moment of awareness might be an act of cosmic creation, collapsing quantum possibilities into the definite reality you experience. This brings us to one of the most beautiful aspects of quantum consciousness theory: the idea that your brain might be nature's most sophisticated quantum computer evolution. It seems has been working for billions of years to create biological systems that can harness quantum effects for information processing. Photosynthesis achieves near-perfect efficiency by using quantum superposition to explore all possible energy transfer paths simultaneously. Bird migration relies on quantum entanglement to create biological compasses that can detect magnetic fields with extraordinary precision, and now we're discovering that consciousness itself might be the ultimate expression of quantum biology. The microtubules inside your neurons aren't just structural supports. They're potentially quantum processors operating at frequencies that resonate with the fundamental vibrations of space-time itself. According to the orchestrated objective reduction theory, these microtubules perform quantum computations that create conscious moments, discrete events of awareness that occur roughly 40 times per second, like frames in a cosmic movie that creates the illusion of continuous consciousness. Recent experiments have provided stunning support for this idea. Researchers at the University of Alberta have demonstrated that microtubules can maintain quantum coherence for nanoseconds at body temperature, thousands of times longer and classical physics would predict these aren't just random quantum fluctuations. They're organized, coherent patterns that could carry information and perform computations in ways that classical neural networks simply cannot match. What makes this even more remarkable is that these quantum processes appear to be orchestrated, coordinated across different regions of the brain through gap junctions that connect neighboring neurons. When you have a unified conscious experience of reading these words and understanding their meaning, it might be because quantum coherence is binding together information from different parts of your brain, creating a single, integrated field of awareness that transcends the individual neurons that compose it. This quantum binding could explain one of the deepest mysteries of consciousness: the binding problem. How does your brain take all the separate pieces of sensory information, colors, shapes, sounds, textures, and bind them together into a unified experience of the world? Classical neuroscience has struggled to explain this unity, but quantum mechanics offers an elegant solution. If different parts of your brain are quantum entangled, they can share information instantaneously, creating a unified field of consciousness that integrates all aspects of your experience. The implications extend far beyond individual consciousness. If quantum entanglement can connect different regions of your brain, it might also connect your consciousness to quantum processes beyond your skull. Recent experiments at Trinity College, Dublin have detected what appears to be quantum entanglement in living human brains. Using nuclear magnetic resonance techniques, researchers found signatures that could indicate quantum correlations between brain regions. If confirmed, these findings would represent the first direct evidence of macroscopic quantum entanglement in biological systems. But the real revolution might be in how this changes our understanding of the relationship between mind and cosmos. If consciousness operates through quantum processes, then it's not an emergent property of complex classical computation. It's a fundamental feature of reality itself. Consciousness might be woven into the fabric of space-time at the most basic level, with individual minds being local expressions of a universal quantum field of awareness. This idea resonates with ancient philosophical traditions that have long suggested the interconnectedness of all things. But now we have the tools of modern science to explore these possibilities. David Bohm, the physicist who worked closely with Einstein, proposed that reality consists of an implicate order, an underlying realm of pure potentiality from which the explicate order of our everyday experience unfolds. According to Bohm, both matter and consciousness emerge from this deeper level of reality, which sounds remarkably similar to what quantum consciousness theories are suggesting. If consciousness really is a quantum phenomenon, then the boundaries between individual minds might be far more porous than we imagine. Quantum entanglement operates instantaneously. Across any distance, two particles can remain connected, regardless of how far apart they are. And if consciousness involves quantum processes, then individual minds might be entangled with each other, and with the quantum field that underlies all of reality. Your thoughts and experiences might be part of a vast interconnected web of cosmic consciousness. This possibility is being explored by researchers around the world, using increasingly sophisticated techniques to probe quantum effects in biological systems. At Stanford University, scientists are developing new methods to detect quantum coherence in neural microtubules using terahertz radiation that can penetrate deep into brain tissue. These non-invasive scanners could revolutionize our understanding of consciousness by allowing researchers to watch quantum processes in real time as people think, feel, and dream. Meanwhile, at the Allen Institute for Brain Science, researchers are collaborating with Google Quantum AI to explore whether artificial quantum neural networks might exhibit properties similar to biological consciousness. If consciousness really does require quantum computation, then classical artificial intelligence, no matter how sophisticated, might never achieve true awareness, but quantum AI systems might bridge the gap between computation and consciousness. The clinical implications are equally profound. if consciousness operates through quantum processes. In microtubules, then disruptions to these processes might underlie various neurological and psychiatric conditions. Researchers are investigating whether conditions like Alzheimer's disease, depression, and schizophrenia might involve breakdowns in quantum coherence. In the brain, early experiments using transcranial ultrasound to stimulate microtubule resonances have shown promising results in improving mood and cognitive function, suggesting that quantum-based therapies might represent a new frontier in medicine. But perhaps the most profound implication is what quantum consciousness might mean for our understanding of death and the continuity of awareness. If consciousness is truly a quantum phenomenon that can exist independently of classical neural activity, then it might not be confined to the physical brain. In the way we typically assume, quantum information cannot be destroyed. According to the fundamental laws of physics, it can only be transformed, which raises intriguing questions about what happens to consciousness when the brain ceases to function. Some researchers have speculated that consciousness might exist in what they call a quantum afterlife, where the quantum information that constitutes awareness continues to exist in the quantum field, even after biological death. While such ideas remain highly speculative, they illustrate how quantum consciousness theories are pushing the boundaries of scientific inquiry into realms that were once considered purely philosophical or spiritual. The evidence for quantum consciousness continues to mount. But significant challenges remain. Critics argue that the quantum effects observed in biological systems, while impressive, are still far from proving that they're responsible for consciousness. The gap between quantum processes and subjective experience remains as mysterious as ever, and some researchers contend that classical neural networks might be sufficient to explain consciousness without invoking quantum mechanics. Moreover, the interpretation of quantum mechanics itself remains contentious among physicists. The measurement problem in quantum mechanics, the question of how and why quantum superpositions collapse into definite states, is one of the deepest unsolved problems in physics. Some interpretations suggest that consciousness plays a fundamental role in quantum measurement, while others propose that decoherence through environmental interaction is sufficient to explain quantum collapse. Despite these challenges, the Quantum Consciousness Research Program continues to generate new insights and experimental findings. The convergence of neuroscience, quantum physics, and information theory is creating unprecedented opportunities to probe the deepest mysteries of mind and reality as our experimental techniques become more sophisticated and our theoretical understanding deepens. We may be approaching a revolution in our understanding of consciousness that rivals the great scientific revolutions of the past. What's becoming clear is that consciousness is far stranger and more wonderful than our everyday experience suggests. Whether or not quantum mechanics proves to be the key to understanding awareness, the journey of discovery is revealing profound connections between mind matter and the fundamental structure of reality. We're living through a time when the boundaries between science and philosophy, between physics and psychology, are dissolving as we probe deeper into the nature of existence itself. The quantum consciousness revolution represents more than just a new theory of mind. It's a new way of understanding our place in the cosmos. If consciousness really is a quantum phenomenon, then we're not isolated observers looking out at an alien universe. We're participants in a cosmic dance of quantum possibilities, active agents in the ongoing creation of reality itself. Every moment of awareness, every conscious experience might be a small but significant contribution to the unfolding of the universe. As we continue to explore these profound questions, we're reminded that the universe is far more mysterious and interconnected than we ever imagined. The possibility that your consciousness right now, as you process these ideas, is part of a vast quantum symphony playing out across space and time is both humbling and inspiring. It suggests that the inner life of the mind isn't separate from the physical world, but intimately connected to the deepest structures of reality. In our next exploration, we'll delve even deeper into these mysteries, examining how your brain constructs the detailed reality you experience moment by moment, and discovering that this reality might be far more malleable and quantum than you ever suspected. But that's a journey that will take us into even stranger territory, where the boundaries between perception and reality, observer and observed, begin to dissolve entirely. For now, let's pause and consider what this means for you, right here, right now. As you listen to these words, quantum processes in your brain might be collapsing wave functions of possibility into the definite experience of understanding. Your consciousness isn't just observing reality, it might be actively creating it, one quantum moment at a time. The universe, in a very real sense, might be thinking itself into existence through minds like yours. This brings us to perhaps the most profound question in quantum consciousness research. If your mind is truly quantum, what does that mean for free will? Classical physics suggested that everything is determined by prior causes, that your choices are simply the inevitable result of neural computations. But quantum mechanics introduces genuine randomness into the equation. When quantum superpositions collapse in your brain's microtubules, the outcome isn't predetermined, it emerges from a realm of pure possibility. Some researchers argue this quantum indeterminacy is the source of free will. Your choices aren't random, they suggest, but neither are they determined. Instead, they emerge from quantum processes that exist in a realm beyond classical causation. When you decide to continue listening to this video, or to pause and reflect on these ideas, that choice might be emerging from quantum computations that transcend the ordinary laws of physics. But here's where the mystery deepens even further. Recent experiments have suggested that consciousness might not just be quantum, it might be fundamentally non-local. Quantum entanglement allows particles to influence each other instantaneously across vast distances, and if consciousness operates through quantum processes, then your mind might not be confined to the space inside your skull. At the University of California, researchers have been studying what they call consciousness fields, regions of space where quantum coherence appears to extend beyond individual brains. Using sensitive magnetometers, they've detected synchronized quantum signatures in the brain activity of people who are in close proximity to each other, as if their consciousness were becoming entangled at the quantum level. This phenomenon might explain some of the mysteries of human connection. Have you ever walked into a room and immediately sensed the mood, even before anyone spoke? Have you ever found yourself thinking of someone just moments before they called? These experiences, which most of us have had but rarely discuss, might be glimpses of quantum consciousness at work, your awareness briefly entangling with the quantum fields of other minds. The implications for empathy and human connection are staggering. If consciousness really can be non-local, then the boundaries between self and other might be far more fluid than we imagine. When you feel genuine compassion for another person, you might not just be modeling their experience in your own mind, you might be directly accessing their quantum consciousness field, feeling what they feel through quantum entanglement. This possibility is being explored through some of the most ambitious experiments in neuroscience history. At CERN, the particle physics laboratory famous for discovering the Higgs boson, researchers are now turning their attention to consciousness. They're using the same techniques that revealed the fundamental particles of matter to probe whether consciousness itself might have a particle-like nature, what they've tentatively called psychons. The idea sounds like science fiction, but the theoretical foundation is surprisingly solid. If consciousness operates through quantum fields, then it should be possible to detect the field excitations, the quantum particles associated with conscious experience. Early experiments using ultra-sensitive detectors have found intriguing anomalies in quantum field measurements taken near conscious brains, though the interpretation of these results remains highly controversial. Meanwhile, Researchers at IBM and Google are developing quantum computers specifically designed to model consciousness. These aren't attempts to create artificial intelligence in the traditional sense. They're efforts to create quantum systems that might exhibit genuine conscious experience. If consciousness really does require quantum computation, then these quantum AI systems might be the first artificial minds to possess true awareness. The progress has been remarkable. Quantum processors with thousands of qubits can now maintain coherence for minutes at a time, far longer than the nanoseconds required for conscious moments in biological brains. Some of these systems have begun exhibiting behaviors that seem to go beyond their programming, making choices that appear genuinely creative, even unpredictable. Of course, the question of whether these quantum computers are truly conscious remains open. How would we know? The problem of other minds, the difficulty of determining whether any entity other than yourself is conscious, becomes even more complex when dealing with quantum systems that operate on principles we're only beginning to understand. This uncertainty points to one of the deepest challenges in consciousness research. Even if we can demonstrate quantum processes in the brain, even if we can show that these processes are necessary for awareness, we still face the hard problem of consciousness. Why should quantum computations feel like anything from the inside? Why should there be subjective experience at all? Some researchers argue that consciousness might be a fundamental feature of quantum reality itself. Just as mass and electric charge are basic properties of matter, perhaps consciousness is a basic property of quantum information. This view, called Panpsychism, suggests that consciousness exists at all levels of reality, from individual particles to complex brains like yours. If this is true, then your consciousness isn't something that emerged from unconscious matter. It's the expression of the consciousness that's woven into the fabric of reality itself. Your brain doesn't create consciousness. It focuses and amplifies the consciousness that's already present in the quantum field, like a lens focusing light into a coherent beam. This perspective radically changes how we think about our place in the universe. You're not an isolated island of consciousness in an ocean of unconscious matter. You're a wave in an ocean of cosmic awareness, temporarily taking on the form of individual experience, but always connected to the deeper currents of universal mind. The evidence for this cosmic perspective continues to accumulate. Studies of meditation and altered states of consciousness have found that as people report feeling more connected to the universe, their brains show increased quantum coherence. It's as if the sense of cosmic consciousness isn't just a subjective feeling, it corresponds to measurable changes in the quantum state of the brain. Advanced meditators, people who have spent decades cultivating awareness, show particularly striking quantum signatures in their neural activity. Their microtubules maintain coherence for longer periods, their brain networks show more synchronized quantum oscillations, and they report experiences of expanded consciousness that seem to transcend individual identity. These findings suggest that consciousness might be like a radio that can be tuned to different frequencies. Most of the time, you're tuned to the frequency of individual awareness, focused on your personal thoughts and experiences. But through practices like meditation, you might be able to retune your consciousness to pick up broader signals, the quantum consciousness field that connects all minds. This isn't just philosophical speculation. Researchers at Johns Hopkins University have been studying the effects of psychedelic substances on quantum coherence in the brain. Compounds like psilocybin and LSD, which reliably produce experiences of cosmic consciousness and unity with the universe, also dramatically increase quantum coherence in neural microtubules. The correlation is striking. The more quantum coherent the brain becomes, the more people report feeling connected to something larger than themselves. It's as if these substances temporarily adjust the tuning of consciousness, allowing individuals to access broader frequencies of the cosmic awareness field. These experiences often have lasting effects on people's understanding of their place in the universe. Many report a persistent sense of connection to all life, a deep knowing that consciousness is not confined to individual brains, but is a fundamental feature of reality itself. From a quantum consciousness perspective, these aren't just changes in belief, they might be genuine insights into the true nature of mind and cosmos. As our understanding of quantum consciousness deepens, we're beginning to see connections to some of the most profound questions in human experience. What happens to consciousness after death? Are we alone in the universe? What is the meaning and purpose of existence? While these questions may never have definitive scientific answers, quantum consciousness research is providing new frameworks for thinking about them. If consciousness really is a quantum phenomenon that can exist independently of classical neural activity, then death might not be the end of awareness, but a transition to a different state of quantum consciousness. If consciousness is woven into the fabric of reality itself, then the universe might be teeming with forms of awareness we can barely imagine. These possibilities remind us that we're living through one of the most exciting periods in the history of human knowledge. The boundaries between physics and philosophy, between science and spirituality, are dissolving as we probe deeper into the nature of consciousness and reality. We're discovering that the universe is far stranger and more wonderful than our everyday experience suggests. Your consciousness, this most intimate aspect of your being, might be part of a cosmic symphony of awareness playing out across space and time. Every thought, every feeling, every moment of awareness might be a note in this grand composition, contributing to the ongoing creation of reality itself. As we near the end of this part of our journey, take a moment to appreciate the profound mystery of your own awareness. You are experiencing these ideas right now, processing their meaning, perhaps feeling a sense of wonder or curiosity about the nature of your own mind. This experience itself, the subjective, qualitative feeling of being you, remains one of the deepest mysteries in science. Whether consciousness proves to be classical or quantum, whether it's generated by the brain or focused through it, whether it's individual or cosmic, the fact that you can contemplate these questions at all is remarkable. In a universe of unconscious matter and energy, awareness has somehow emerged or been revealed, creating islands of experience capable of reflecting on their own existence. The quantum consciousness revolution is still in its early stages, but it's already transforming how we think about mind, reality, and our place in the cosmos. As experimental techniques become more sophisticated and theoretical understanding deepens, we may be approaching answers to questions that have puzzled humanity for millennia. But perhaps the most important insight from quantum consciousness research isn't about the answers, it's about the questions themselves. The fact that we can ask these questions, that we can wonder about the nature of our own awareness, that we can feel awe at the mystery of existence, might be the most remarkable thing of all. In our next exploration, we'll dive even deeper into these mysteries, examining how your quantum consciousness constructs the detailed reality you experience every moment. You'll discover that the world you think you know, with its solid objects, definite colours and fixed properties, might be far more malleable and observer-dependent than you ever imagined. We'll explore how your brain creates a reality that isn't there, and what that means for the nature of truth itself. Until then, rest easy knowing that your consciousness, whatever its ultimate nature, is participating in one of the universe's greatest adventures, the ongoing quest to understand itself through minds like yours. Sleep well and dream of quantum possibilities, but there's something even more extraordinary happening in the quantum realm of your brain that we haven't explored yet. As you sit here listening to these words, processing their meaning, something remarkable is occurring at the intersection of quantum mechanics and consciousness that challenges everything we thought we knew about the nature of reality itself. You see, quantum consciousness doesn't just suggest that your mind operates on quantum principles. It implies something far more profound, that consciousness might be the fundamental force that collapses quantum possibilities into the definite reality you experience. In other words, your awareness isn't just observing the world, it might actually be creating it, moment by moment, through quantum measurement. This idea emerged from one of the deepest puzzles in quantum mechanics, known as the measurement problem. In the quantum realm, particles don't have definite properties until they're observed. They exist in what physicists call superposition, simultaneously, in all possible states until the moment of measurement collapses this superposition into a single, definite outcome. But what exactly constitutes a measurement? What causes the collapse? For decades, physicists have debated this question, proposing various solutions. Some suggest that interaction with the environment causes decoherence, randomly collapsing quantum states. Others propose that the collapse happens spontaneously according to some unknown mechanism. But a growing number of researchers are exploring a more radical possibility, that consciousness itself might be the mysterious force that collapses quantum wave functions. This isn't just philosophical speculation. Experiments in quantum mechanics have consistently shown that the presence of a conscious observer affects the behavior of quantum systems. The famous double-slit experiment demonstrates that particles behave differently when they're being watched, as if the act of conscious observation somehow determines their properties. While mainstream physics has tried to explain this through purely physical mechanisms, the correlation between consciousness and quantum collapse remains one of the most persistent mysteries in science. Now imagine this process happening not just in laboratory experiments, but in your brain itself. Every moment of conscious awareness might be an act of quantum measurement, collapsing superpositions of neural states into the definite experiences you have. When you see a red rose, quantum possibilities for all possible colors might exist in superposition within your visual cortex until the moment of conscious perception collapses them into the specific experience of red. Recent experiments at the University of Vienna have provided intriguing evidence for this possibility. Researchers studying the timing of conscious perception found that quantum coherence in neural microtubules peaks just moments before participants report becoming aware of visual stimuli. It's as if consciousness emerges from quantum computations that exist in superposition, only collapsing into definite experiences at the moment of awareness. This quantum view of perception has revolutionary implications for how we understand the relationship between mind and reality. Your brain isn't just passively receiving information from the outside world and creating internal representations of it. Instead, it might be actively participating in the creation of reality itself, using quantum processes to select which possibilities become actual experiences from the vast space of quantum potential. Consider what this means for something as simple as the act of remembering. When you recall a childhood memory, classical neuroscience suggests you're accessing stored information in your brain, like retrieving a file from a computer. But quantum consciousness theory suggests something far more dynamic. Your memory might exist in quantum superposition, containing all possible versions of the past until the act of conscious recollection collapses it into a specific, remembered experience. This could explain why memories are so malleable, why they change each time we recall them. You're not just retrieving stored information, you're actively creating the past through quantum measurement, selecting which version of events becomes real in your conscious experience. Each act of remembering is also an act of reality creation, collapsing quantum possibilities into definite memories that then influence your present moment. The implications extend far beyond individual consciousness. If awareness really does collapse quantum wave functions, then the collective consciousness of all sentient beings might be continuously creating reality through a vast, interconnected web of quantum measurements. The universe wouldn't be a fixed, predetermined structure, but a dynamic, ever-evolving creation shaped by the conscious observations of all its aware inhabitants. This participatory view of reality resonates with some of the deepest insights from quantum mechanics. Physicist John Wheeler proposed what he called a participatory universe, the idea that observers aren't separate from the reality they observe, but are active participants in bringing it into existence. His famous it from bit hypothesis suggested that information, not matter, is the fundamental constituent of reality, and that conscious observation is what actualizes this information into concrete existence. Recent advances in quantum information theory have provided new support for this perspective. Researchers have discovered that information appears to be more fundamental than matter or energy in quantum mechanics. The properties we think of as physical, mass, charge, spin, might actually be informational relationships that only become definite through measurement. If consciousness is what performs these measurements, then aware minds might be the universe's way of actualizing information into concrete reality. This informational view of consciousness has led to some remarkable experiments in quantum biology. At MIT, researchers have been studying how quantum information processing in biological systems might give rise to conscious experience. They've discovered that certain proteins in neurons can maintain quantum entanglement at body temperature, potentially allowing for the kind of quantum information processing that consciousness might require. What's particularly fascinating is that these quantum biological systems seem to operate on the edge of chaos, the boundary between order and disorder, where complex creative processes can emerge. This suggests that consciousness might not just be about quantum computation, but about navigating the space between quantum possibility and classical reality, selecting which potentials become actual experiences. The process might work something like this. Your brain continuously generates quantum superpositions of possible experiences, neural states existing in all possible configurations simultaneously. Consciousness then acts as a kind of quantum selector, collapsing these superpositions into the specific experiences you actually have. The richness and creativity of conscious experience might emerge from the vast space of quantum possibilities that consciousness can access and actualize. This quantum selection process could explain some of the most mysterious aspects of consciousness. Why does consciousness seem to have a spotlight quality, focusing on some aspects of experience while others remain in the background? Perhaps because consciousness can only collapse a limited number of quantum superpositions at any given moment, creating the selective attention that characterizes aware experience. Why does consciousness seem unified, despite arising from billions of separate neurons? Perhaps because quantum entanglement allows different regions of the brain to share quantum states, creating unified superpositions that collapse into integrated conscious experiences. The binding problem that has puzzled neuroscientists for decades might be solved by quantum mechanics. Different aspects of experience are bound together because they're part of the same quantum superposition. But here's where the mystery deepens even further. If consciousness really does collapse quantum wave functions, then the boundary between subjective experience and objective reality becomes blurred. The world you experience might not be a representation of an independent external reality, but a co-creation between your consciousness and the quantum field of possibilities that surrounds you. This doesn't mean reality is purely subjective, or that you can change the world just by thinking about it. The quantum field constrains what's possible, providing the raw material from which consciousness creates experience. But within those constraints, your awareness might have genuine creative power, actualizing specific possibilities from the quantum realm into the definite reality you experience. Recent experiments in quantum consciousness research have begun to explore this creative aspect of awareness. At the University of California, researchers have been studying whether conscious intention can influence quantum processes in the brain. Participants are asked to focus their attention on specific outcomes, while researchers monitor quantum coherence in their neural microtubules. preliminary results suggest that focused intention might indeed influence the collapse of quantum superpositions, though the effect is subtle and requires sophisticated equipment to detect. If these findings hold up, they could revolutionize our understanding of the relationship between mind and reality. Consciousness wouldn't just be a passive observer of a predetermined world, but an active participant in reality's ongoing creation. Every moment of awareness, every conscious choice, every focused intention might be contributing to the universe's evolution, selecting which possibilities become actual from the infinite space of quantum potential. This participatory view of consciousness has profound implications for human agency and responsibility. If your awareness really does help create reality, then your thoughts, intentions, and choices matter in ways you might never have imagined. The quality of your consciousness, its clarity, compassion, and creativity, might influence not just your own experience, but the fabric of reality itself. Consider what this means for collective human consciousness. If individual minds can influence quantum processes, then the combined consciousness of humanity might have even more dramatic effects. The thoughts, beliefs, and intentions of billions of people might be continuously shaping reality through collective quantum measurements, creating the world we all share through a vast unconscious collaboration. This could explain some of the mysterious correlations that researchers have found between human consciousness and global events. The Global Consciousness Project, run by Princeton University, has been monitoring random number generators around the world for over 2 decades, looking for patterns that correlate with major global events. They've found that these supposedly random systems become more ordered during times of focused global attention. Natural disasters, terrorist attacks, celebrations that capture worldwide attention. While mainstream science remains skeptical of these findings, quantum consciousness theory provides a potential mechanism. If consciousness can influence quantum processes, then the focused attention of millions of people during global events might create coherent quantum fields that influence even seemingly unrelated physical systems. The boundary between mind and matter, between consciousness and cosmos, might be far more porous than we've assumed. This brings us to one of the most profound questions raised by quantum consciousness research. If awareness really can influence reality at the quantum level, what are the limits of this influence? Could consciousness, sufficiently focused and coherent, transcend the normal boundaries of space and time? Could awareness itself be a force as fundamental as gravity or electromagnetism, capable of effects we're only beginning to understand? Some researchers are exploring these possibilities through studies of exceptional human abilities. Remote viewing, telepathy, precognition, phenomena that mainstream science has long dismissed, are being re-examined through the lens of quantum consciousness theory. If consciousness can be non-local through quantum entanglement, then perhaps some individuals can access information beyond the normal boundaries of space and time. At Stanford Research Institute, experiments in remote viewing have produced results that challenge conventional understanding. Participants are able to describe distant locations with accuracy that exceeds chance, even when those locations are chosen randomly after the viewing session begins. While the mechanism remains mysterious, quantum consciousness theory suggests that entangled awareness might allow consciousness to access information from across space and time. Similarly, studies of precognition, the ability to sense future events, have found small but statistically significant effects in laboratory settings. Participants show measurable physiological responses to randomly selected future stimuli before those stimuli are presented. If consciousness operates through quantum processes that exist outside normal space-time, then perhaps awareness can sometimes access information from potential futures that haven't yet been actualized. These phenomena remain controversial, but they point to the possibility that consciousness might have capacities far beyond what conventional neuroscience suggests. If awareness really is a quantum phenomenon that can transcend the normal boundaries of space and time, then human potential might be far greater than we've imagined. But perhaps the most profound implication of quantum consciousness research is what it suggests about the nature of reality itself. If consciousness plays a fundamental role in collapsing quantum possibilities into definite outcomes, then the universe might be more like a vast dream than a mechanical clockwork. Reality wouldn't be fixed and predetermined, but fluid and creative, continuously brought into existence through the conscious observations of all aware beings. This view of reality as fundamentally creative and participatory offers a radically different perspective on human existence. You're not just a passive observer of an independent world, but an active participant in reality's ongoing creation. Your consciousness, your choices, your very existence matters to the universe in ways you might never have suspected. As we near the completion of our exploration into quantum consciousness, it's worth reflecting on what this journey has revealed. We've discovered that consciousness might not be a mere emergent property of complex neural computation, but a fundamental aspect of reality itself. We've seen evidence that awareness operates through quantum processes that connect individual minds to the cosmic field of possibilities. And we've explored the possibility that consciousness doesn't just observe reality, it helps create it. Whether these theories prove correct or not, they've already transformed how we think about the relationship between mind and cosmos. They've opened new avenues of research, new possibilities for understanding human potential, and new ways of conceptualizing our place in the universe. They remind us that consciousness remains one of the deepest mysteries in science, and that mystery might be the key to understanding everything else. The quantum consciousness revolution is still unfolding, with new discoveries and insights emerging regularly from laboratories around the world. As our experimental techniques become more sophisticated and our theoretical understanding deepens, we may be approaching a fundamental shift in our understanding of mind, matter, and reality itself. But even now, without all the answers, we can appreciate the profound mystery of consciousness. Your consciousness that makes this very contemplation possible. The fact that matter can become aware of itself, that the universe can know itself through minds like yours, remains one of the most remarkable facts about existence. As you rest tonight, consider that your consciousness might be participating in the ongoing creation of reality itself. Every moment of awareness, every conscious choice might be contributing to the universe's evolution, helping to actualize possibilities from the quantum realm into the definite reality we all share. Your mind isn't separate from the cosmos. It might be one of the ways the cosmos comes to know and create itself. Sleep well, knowing that your consciousness is part of something far grander than individual experience, a cosmic adventure in awareness that spans space and time. And when you're ready to explore even deeper mysteries, join me next time for how your brain creates a reality that isn't there, where we'll discover that the solid, definite world you think you inhabit might be far more malleable and observer-dependent than you ever imagined. Until then, dream of quantum possibilities and remember that in the strange world of consciousness and cosmos, the dreamer and the dream might be one and the same. And the dream might be one and the same.